Howdy. Today we will be speaking about AI and nanoparticles and how they are both involved in the medical field. This was brought to you by me, Patrick, and my partner, Nehemiah.
Howdy.
Now I will pass it on to my partner in order to start off this presentation.
Hello. So, the first thing I'll be talking about are the types of nanoparticles used in our first article. So, most of the nanoparticles that were used were metal oxides, which are shown in the picture next to it, which consists of iron oxide and TiO2. And the other nanoparticles used were metallic categories, which end up being Au and Ag. So, the metal oxide nanoparticles have a huge range of shapes, so it's not really bounded by a whole lot. But it does tend to range from 1 to 100 nanometers in size, while the metallic nanoparticles tend to be octahedrals, decahedron, isosahedron, and cubic. So it actually ends up ranging from 10 to 100 nanometers, which is about the same as the first one. So what are the applications of these nanoparticles in this study? So in this study, they used nanoparticles from all different types of different studies they had, which range from different places, different patients they were used on, even different organisms, and even different places they were used on within the patients. So some of the applications of these were the drug delivery system, molecular imaging, and diagnosing slash treating diseases. So what we want to know is the importance of toxicity levels. With these toxicity levels, we want to know how it affects the patients. And within this graph shown to us right now, we can see where we got its source from, the country it originated from, the aim, which tends to be to predict the toxicity levels of nanoparticles, the types of nanoparticles used, where it was used on, like lung cells, and even just rodents or just lungs in general, the data set, the model, and even the AI method used on these to try and calculate the toxicity levels. So what were these used for? In the graph prior, we see multiple different cases used, and that was only a portion of what we had. But it mainly talked about lungs, normal cells, and even cancer cells. And some of them were used on bacteria and algae, but they were used a lot on different parts of the lung and different cells, specifically in order to deliver drugs and even find out what diseases were used. So, using nanoparticles and AI together. So, using understanding the nanoparticles at work, we can find how they affect different areas within these studies and use the AI to predict other trends that could happen with different nanoparticles. For now, we're stuck with the two nanoparticles we're discussing, but if it were to be developed more, we can not just be limited to the range of these two nanoparticles, but spread multiple into different ranges of them. So maybe even predict what could happen and stop toxicity levels from increasing and poisoning patients. I would like to pass this on to my partner, Patrick.
Howdy. My name is Patrick, and I will be talking about how nanoparticles and AR are used in the medical field through the detection of cancer cells. So, what type of nanoparticles were used in my experiment or article that I was reading? The type of nanoparticles used were nanocarriers, which specialize in delivering, um, let's say, medicine, or mainly it could just be any item inside of the host, which would be the patient or potentially an animal. So in this article, we can see in the picture here in the bottom left that the nanocarriers could come in all shapes, such as nanospheres, which can range from 1 through 100 nanometers, nanorods, which can range from, well, just 50 nanometers, nanoshells all the way to 140 nanometers, and nano cages, which are kind of like nanorods, 50 nanometers. This provides a variety and diversity of nanocarriers for different entry sites within the host. So, what was the application of these nanoparticles? In this article, the main goal was to try and combat TNBC, which is according to the article, the most aggressive subtype of breast cancer, which would be triple negative breast cancer, which is found in women, of course. And in order to combat this issue, the article speaks about using nanocarriers in order to carry and detect these cancer cells and be able to combat them with medicine. We can see that in this picture would be like a really useful application of these nanoparticles because we can see the nanocarrier combating the cancer cell at first because it would be first detected and then it would then be attacked with medicine. So you might be wondering, what exactly did these nanocarriers do? So first, the scientists in this experiment, they first acquired these nanocarriers to work with, of course. And then with the power of AI, these nano carriers were taught by three different AI softwares, which include Inception v3, VGG16, and ResNet 50. These software AIs would help these nanoparticles learn how to detect these cancer cells within the host by creating images of what could possibly be a cancer cell within the host's body, and it would either be in high or low resolution to increase difficulty, one could say. And then the job of these nano carriers would be to detect these nano, I mean, these cancer cells within the body. And once these cancer cells are detected, the nano carrier can now carry the medicine within its system in order to combat the cancer within the host's body. As we can see here, we see the low and high quality cancer cell pictures, and this was provided by the three software AIs. So how can we improve this upon the future? So we know that using these nanocarriers to combat cancer cells are very useful. However, this we know that this isn't going to be cheap. So in the future, we could, of course, we can try and make the nanocarriers with less expensive material, or we can use a lot more accurate softwares AIs in order to teach these nanocarriers on the detection of cancer cells and also the delivery of oops, the delivery of these drugs. Not only that, we know that of today, there is still some percentage error that can be found within these operations, such as the delivery and the detection of these cancer cells by the nanocarriers. So in the future, if our AIs that are going to be teaching these nanocarriers how to detect cancer cells and combat them with the medicine provided, we can reduce this percentage error, which would increase the percentage of people surviving breast cancer due to these nanocarriers. And not only that, our technology would be a lot more advanced, which can make this process a lot quicker and could also make these nanocarriers smaller so that they can come in larger numbers. We can see here in the image how theoretically it will look like a cancer cell being attacked by nanocarriers with the medicine that they have inside their system. These were the references used by me and my partner Nehemiah, and I would like my partner to end up this presentation. You're on mute.
I'd like to thank you for the time you've given us in order to review our presentation and give us the thought. Thank you and goodbye. Thank you.
Bye.